waves. And I told you they are authenticated. There's some special infrastructure authentication method involved, which is called LEAP, like a lightweight EAP. It's a Cisco proprietary protocol, and remember, I mean, I think it was in the end of 2005, Joshua Wright gave a talk at, I think this was DEF CON, right?
No, I think, did Joshua give us, when did he release SLEAP? Wasn't it at Shmoo?
Was it?
I think it was at Shmoo.
At Shmoo or somehow. In 2005, he showed LEAP is basically is basing on a challenge response mechanism. And then you have some, let's say, some encryption key which is too short and revealing some bytes and so on. The overall picture is you can, if you have a sufficient large word book, you can break authentication based on LEAP within seconds. This is, I mean, you're doing infrastructure authentication and you're able to break it within a short time, which is, think about building up trust with a broken mechanism. This is it. And so we thought about how should this work in a secure manner? Is it possible in any way to do it in a secure manner? If you read the patent application, Cisco says, oh, hey, we know Cisco LEAP is insecure and somehow it's related to password strength and all that stuff. So we do use another key. We introduce another key for encryption and authentication, which is not LEAP, but somehow if you look at the key derivation, I will show it to you in a moment, the key is, or the key which is derived by LEAP is somehow involved in the new key generation mechanism. So this is like building a house on sand. It will drown it some time. So this is where we think about, hey, you're doing infrastructure authentication, you're trying to build up trust, and you do it on broken mechanisms, and you say, oh, we are secure because we have a separate encryption key, but it's all based on an insecure mechanism. And it was about to say, let's prove that it's really insecure, that it's hackable. And it took some time. What happens in the background is just a normal LEAP authentication as you would have it within, let's say, a wireless network protected with LEAP. And so you have a look at the packet, you dissect the packets and all that stuff, and then you can just take that data out of it, put it into ASLEAP, and ASLEAP gives you the password, which was used for authentication. And that password is really, this is important. Because of the password, there is this so-called network session key derived. The network session key is the keying material, which would also be used if you have LEAP in a wireless environment. And then they say, okay, now we do a new key derivation, the context transfer key, which is for encrypting and authentication critical data like pairwise master keys we transfer between the different APs. And if you look at the on the key derivation scheme, it's totally easy. The so-called PIF function is the same key generation function which is used within wireless. It's a standard function. The function is okay. The function is secure. You just what this function essentially do is an HMAC SHA1, and you have some input data. The input data is somehow, of course, the so-called network session key for the HMAC, and there's some, let's say, they just put it all together to a string and then derive the key on it. There's some string called SWAN, EN to EA, link context transfer key derivation, which is just some random string. And then they have these IDs for the access point who is just authenticating, and the authenticator, which is the WDS master. And then these two devices just exchange a nonce between each other. This is all. And you just take all that data, put it in the PRF function, and you get a context transfer key. And you take that key, which is with HMAC based on the already broken LEAP key, and encrypt and authenticate data with it. Honestly, this is insecure. This is where we say this is a bad protocol design, because it's known that LEAP is insecure and that you can break it. And I mean, the funny thing, I mean, if you look at on the market, this infrastructure was sold around 2005. And Cisco was already aware of leap vulnerabilities, but they did it. They just did it. So how could a practical attack be? The first thing is you need to get access to that, we call it wired backbone of the APs, which is just the distribution set where all this communication takes place. So the easiest thing might be just find an access point, pull out the cable, and connect your notebook to it, which guess will work in nearly every deployment. So the next thing is identifying which devices are capable of speaking WLCCP, which is a trivial task because it's UDP encapsulated. Just take Nmap and you will find them all. It's not a problem. The next thing is you just need to find who's the WDS master, which is trivial again because it announces itself in layer 2 packets. You just listen on the interface and you get to know who's the master. And then just take your list of WLCCP speaking devices, cut out the master, and then you have then you know where infrastructure authentication is taking place. And you just have to somehow tear down this already authenticated communication, which is like let's send, like the demo Enno and Daniel just showed, like sending out faked advertisements, like ARP spoofing, whatever you want to. The only essential thing is you need to have access to the packets carrying all the authentication data, and but that's okay. And then it's some code. It's just a bigger bunch of code which does all the packet analyzation and the cracking, and then you get everything you need, including this context transfer key to encrypt all the other packets, and of course introduce your own packets into the infrastructure. You can say like, hey, give me the pairwise master key of the following mobile node if you have a correct CTK. So this is why the CTK is so important. So now we will show it to you in a practical way. We coded that stuff. Show it to you in just a... Yep. Just to have to restart my PuTTY session. So here we go. So the tool is currently, we call it WLCCP crack. We didn't came up with a better name until now, but maybe that will change. Don't know. So the important thing is, of course, you need to be root for that kind of attacks. And you just fire up the utility, and currently there's debugging enabled, and it dissects you the known WLCCP packet, so you can have a look into it. So I'm simulating an attack by just unplugging the cable, which is essentially like you have somehow spoofed the WDS master, you have done ARP poisoning, or anything else. It's just, it's nearly the same. Just tearing down that already authenticated channel. And from that moment the device recognizes it, it just starts to get the authenticated channel back on. And this is what we are waiting for. I hope that should be enough of time. It nearly takes about 20 to 40 seconds. So, and then this will be... So, let's see. No, that was too short. Shit. So you see, this is the most critical part of it. You have to wait for the right time until this authenticated connection drops down. But this is everything. So this, what we see here, I will tell you a little bit about what you see. You see, this is data, and currently these are packets Daniel just crafted with his tool. What you normally see is the advertisement of the master saying, hey, I'm here, and it doesn't